All right, 5.3a, we're going to do the pre-calc version of it first. So from pre-calc, Algebra 2 days, what was an inverse? It was a what? It was a switch in x and y. All right, so we're going to do a lot of ordered paired systems here. So if I have an inverse f, if I have my ordered pair as 2, 3, what would the ordered pair of my inverse be? 3, 2. Because it's a switch in x and y. My x's and y's switch. My domains and ranges, they switched. All right, so graphically, again, it's just a switch in x and y, which means it's reflective upon the line y equals x. So to have an inverse, to actually have a function that has an inverse, it has to pass both the vertical line test to be a function, and it has to pass the horizontal line test because why? It's a what? Switch in x and y. So, for instance, would that function have an inverse? No, because that doesn't pass the horizontal line test. All right. However, would that function have an inverse? Yes, because that would pass both. Right. So look at this one. If we look at x cubed plus x minus 1, does that function actually have an inverse? Yes, that would definitely have an inverse. Whee. All right. However, x cubed minus x plus 1, would that have an inverse? No. All right. All right, so that one wouldn't actually have an inverse. Okay, does that make sense? Now, second pre-calc, again, what was an inverse? It was a what? Switch in x and y. And so back then, we actually found the inverse of a function. So that's what we're going to do right now. So the first step is to switch x and y. So now we have x is equal to square root of 2y minus 3. And then we do what? We solve for y. And so what's my first step on solving for y on this one? Square both sides. So now I have x squared is equal to 2y minus 3. And we're smart people. We can do this in one shot. What could we do now? Add 3 and divide by 2. So now I end up having y is equal to x squared plus 3 all over 2. Right? And the last step of it was not to have y. It was actually to say it's what? F inverse of x is equal to x squared plus 3 all over 2. And that's a really good technique when we can actually solve for the inverse. Are you following me? However, sometimes we can't. And that's why we need calculus. So this is the calculus part of our inverse functions. This is where I'm going to spend the bulk of my time today. So I'd like you to graph x cubed and x to the 1/3 all in the same window on your calculator. Graph x cubed and x to the 1/3 all in the same window. So now what we're going to do with them is we're going to find the slopes at these different points. So for my x cubed function, I'm going to find the slope at 1. So I'm going to do second calculate, and then which one says slope? dy dx, right? That's our slope. So we go down to our number 6, we press enter, and then I want it at 1. So let's type in 1, and I'm going to press enter. So what did it pop up to say dy dx is equal to? No. 3.001, right? Now, I'm not going to get into it too much right now, but the way the calculator works is that it rounds things. It really shouldn't have a 1 at the very end. All right?
It should just be 3.
It should just be 3. You're right. All right? So now, g of x is the inverse of f. So what I want to do is now I want to do second calculate. I want to find the derivative, my slope, at 1. Now, this one's at x cubed. You see how it's in the top left?
Yeah.
Okay? So if you toggle down, if you press your down arrow, you see now it has the function x to the 1/3?
Yes.
All right? So now let's type in 1. And now, what is my slope there? 0.34, right? 0.333. Well, what is that 0.333? It's 1/3. Huh, how about that? All right, so let's do it again. So now let's find our slope at 2 of that original function. So second calculate, dy dx, and now I'm going to do it at 2. And so what do we get our slope of f at 2? 12. All right. Now I want to find my slope of my x to the 1/3 at 8. I want to find my slope of x to the 1/3 at 8. So let's do second calculate, dy dx. Make sure you get to the 1/3 one, and I want it at 8. And so we end up getting what? 0.08333 repeating, right? Do you know what that is? What? It's 1/12. Exactly. Interesting. All right, let's do it again. So now I want to find my slope at 3 of the x cubed. So we're going to do second calculate, dy dx, at 3. And what do we end up getting? We get 27. Now, without even doing this next one, what do you think the slope at 27 is of the other one? What? 1/27. Now, what did we notice? What did we notice? It's the reciprocal. Exactly. Now, was it the reciprocal at the same x value, though? No. What needed to happen before we did anything? The switch in x and y. Exactly. The 1 is the same, right? Because my x's and y's are the samesies, right? However, when I get to do this slope of 2, 8 of my original function is 12. Is my slope at this one at 2 1/12? No. It's at what? It's at 8. Because why? They are what of each other? They are inverses. Because inverses are what? A switch in x and y. You see how they're related? So I have to have an inverse, a switch in x and y, and then how are their slopes? How are their slopes relationships? They are what? They are reciprocals. All right. All right. So this is the book version. Okay. And my first year teaching it, this is the way I taught it. So if g and f are inverses of one another, the way we actually find an inverse is f inverse prime of x would be equal to 1 over f prime of the f inverse of x. All right. This is the book technique. And my first year teaching calculus, that's the way I did it. I want you to write it down. However, I don't really use it this way. I think there's a better way. I like to use ordered pairs, and I think you'll see how we use them. All right. So, to find an inverse derivative, it would be 1 over f prime of the inverse of x. All right, that's actually the book technique of doing it. It's not wrong. However, I think it's an easier way. Good? All right, so let's write this out. So I have my function is x squared. All right, my function is x squared. F of x is equal to x squared. Now, how could I get an inverse here? How do I get an inverse of this function? I switch x and y, right? And then I solve for y. So if I switch it, I'd have x is equal to y squared, right? Yeah. And so then I'd solve for it, I'd square root it, so I get y is equal to square root x, right? So those are inverses of one another. I could totally do that real easy with my pre-calc algebra 2 skills, right? All right. So let's prove these. Let's prove how this works. So if I have the ordered pair 2, 4, I want to prove that these things are reciprocal functions. So if I have f prime, what would f prime end up being? If f of x is equal to x squared, what's f prime? It's not a trick question. 2x, right? Just a little power rule. All right. So that's what f prime is. True? Well, what if I find f prime at 2? What would f prime at 2 be? 2 times 2 is 4, right? What do I know, without even proving it yet, what derivative I know? What would my f inverse prime that I know be? F inverse prime at, not 2, but 4. What would f inverse prime at 4 be? 1/4. Okay, because it's a switch in x and y, and then they are reciprocals. Now, I want to prove this one. Okay, we know that f inverse is square root x. True? We know that. So I want to find f inverse prime. I want to find f inverse prime.
Wait.
All right. So let's take a derivative. What could come out front? If I could think of this as like an x to the 1/2, right? So that's f inverse. Yes?
Yes.
All right. So what comes out front? A 1/2. And then I'd have x to the what? Negative 1/2. So my f inverse prime would equal 1/2 square root x. True?
Yes.
All right. So now, what do I know f inverse prime of 4 is? What would it be? If I substitute in 4 right here, what would it be? 1/4. All right. Now, did I actually need that inverse function at all? I didn't. All right. And I want to prove part B to us now. So if I have the ordered pair 3, 9, so what would I know f prime at 3 would be? What do I know f prime at 3 would be? 2 times 3 is 6, right? So knowing that, and I know my ordered pair is 3, 9, f inverse prime at what do I know?
9.
9 is equal to
1/6.
1/6. Okay? Because what's an inverse? It's a what? Switch in x and y. And how are their derivatives related? They are what? They are reciprocals. All right? Now, this was really easy to prove because we could actually find f inverse. Okay? When we can't, that's why we need calculus. So let's write this one out. So now I have f of x is equal to 1/4 x cubed plus x minus 1. And what I want to find eventually is I want to find f inverse prime at 3. That's what I want to find. I want to find f inverse prime at 3. Okay? So the way that I like to do it is I like to find ordered pairs. And I have to use calculus because can I actually solve for the inverse of this function? Let's switch x and y. Try it. Switch them in. Can we actually solve for y? No. So thank goodness we have calculus. This is good. All right. So I want to find the slope of my inverse at 3. So I like you to write out the ordered pair method. All right. So I'm going to have an f and I'm going to have an f inverse. And my f inverse, my x value is going to be 3. Well, what do we know my f value? Do I know my x or do I know my y?
X.
I know my y. My y would be 3. Why is that? Because they are what? A switch in x and y. Okay, it's not a reciprocal yet. All right. So what do I need to solve for? The x value of f. So here we go. So I'm just going to substitute in 3. And so I'm going to find 3 equals 1/4 x cubed plus x minus 1. Now, you don't hear me say this often. Guess and check is actually the best method we got going on right now. All right. If we were to actually try to solve this using other techniques, you might get there. But honestly, guess and check's better. So what do we want to try? What? 2 sounds good. I like 2. So let's try 2. So 2 cubed would be what? 8. 8 divided by 4 is 2. 2 plus 2 is 4. 4 minus 1 is 3. That's awesome. So I get an x value of 2. And so what I want to find is I want to find f prime. And what would f prime be? Let's take a derivative here. What's my derivative? 3/4 x squared plus 1. All right. And what do I want to evaluate f prime at? Eventually, I want to get f inverse prime at 3. That's eventually what I want to get to. But I want to find f prime at what? 2. So f prime of 2 is what? So what do we know? F inverse prime at 3 is equal to what? 1/4. Do I know anything about F inverse? Not really. Not much at all. However, I know the slope at 3 is 1/4. Because what's an inverse? It's a what? Switch in x and y. And then how are they related? The slopes are reciprocals of one another. All right. All right. So I'd like to write out this table now. Okay. AP loves these little tables. They're real simple after we do them a little bit. It's not hard. It's just what? Different way of thinking. Okay. And I'd highly advise you writing out the ordered pairs. All right, so the first thing we're going to be asked is F inverse prime of 4. So what I highly recommend doing is write out your ordered pairs right now. So I want to find F inverse and I want to find F. Well, F inverse is going to be at 4. So what do we know my F is? What do I know about my F? The Y value is 4. So I need to look to see where my Y value of F is 4. And where is that? It's right there. It's at 2. So my X is 2. See how that worked? Now, what I want to do is I want to find F prime at what? At 2. I want to find F prime at 2. And so F prime at 2 is what? -2. So what do I want to actually find? I want to find F inverse prime at 4, which is what? -1/2. Because how are they related? They are what? They are reciprocals. Okay, pretty easy. Not hard, it's just say what? Different way of thinking. All right, let's do it again. So now we're going to find F prime at 3. Do I actually need to write out an ordered pair here? I don't need to. All right, it can tell me right now. What's my F prime at 3? -1. Pretty simple. All right, let's do this next one. So now I want to find F inverse prime at 1. I want you to write out your ordered pairs right now. I know some people can probably already do it. So I want to find F inverse, and I want to find F. So my F inverse, what do I know? My X value is 1. So now what do I need to know? My Y value of F is 1. So where is my Y value 1? At 4. All right. Now, do we actually care what this Y value is right here? Not really, but what is it? It's 4. Okay. We don't really need to know it, but it's there. All right. So then, what is my F prime at what? 4. So what is F prime at 4? 0. All right. F prime at 4 is 0. So what do we know F inverse prime at 1 is? It's undefined. All right. Because if I flip it, I'd have 1 over 0, which would be undefined. All right. Pretty good. All right. What's an inverse? It's a switch in x and y. After you switch the x and y, how are their slopes related? They are reciprocals. All right. Pretty good. All right. So on your worksheet, I'd like you to do numbers 7 through 15, and then a little bit from your book.